Okay, so chapter 7, these 3 sections that we'll do in chapter 7 are mostly about inequalities and applications of inequalities. We tend to think of them in a business idea as restrictions. Restrictions on what we can do. Most of the times companies would love to make a certain amount of profit, but they have restrictions, the amount of space they have to create things, the amount of money they have to spend on products to help make whatever they want. So these chapters are about how to maximize your potential based on potential restrictions you might have. So first, let's talk about inequalities. A linear inequality in 2 variables is of the form ax plus by is less than or equal to c. It could be less than or equal to, greater than or equal to, less than, greater than. Depends. It's just we've got 2 variables and a constant and some kind of inequality. To graph these, we first treat it like there's an equal sign. And then once we find the line, we graph the line either as a solid line if there's an equal to sign, or a dotted line if it's just greater than or less than. And we either can test points on either side to see if that side should be shaded, or you can use the concept of what's greater than or less than. Of course, the easiest point to plug in is 0, 0, because that's the easiest number to plug in is 0. Now, if we're going to graph 3x minus 2y is less than or equal to 6, you can solve for y. Negative 2y is less than or equal to negative 3x plus 6, and divide by negative 2 to get y is now greater than or equal to 3 halves x minus 3. Now remember, when you multiply or divide by a negative number, the direction of an inequality changes. So y is greater than or equal to 3 halves x minus 3. Because we have an equal to sign, we're going to graph y equals 3 halves x minus 3 normally. So start at the negative 3. We have a rise over run of 3 over 2. And you can also go down 3 and left 2 as well. So this is our line. Now, we know we're looking for the y values that are technically above the line. So most of the time, people can look at this and tell where above the line is or not. I call it like the coin trick. If I drop a coin from this side, will it eventually land on the line? Yes, that means it's above the line. Dropping a coin over here, though, will never land on that line. So it's below the line. So we expect it to be this left area. But of course, I can always plug in 0, 0. Is 0 greater than or equal to 3 halves times 0 minus 3? Well, is 0 greater than or equal to negative 3? Yes, which means 0, 0 is on the side I should be shading. So I know that side is this side over here. And you can roughly shade. On your homework, there's a shading little option that'll help you shade the line. But this is how it works, generally speaking. So let's keep going, because eventually we need to get to systems and not just single equations. So let's just remind ourselves of a few more things. Graph the solution so that x is less than 6. So if you have just an x equals line, that's a vertical line. Just a y equals line is a horizontal line. So when x is less than 6, you draw a vertical. This is a dotted line because there's no equal to sign. Now which areas is x less than 6? Again, you can plug 0, 0 in. There's only an x to substitute for. 0 less than 6, yes. So generally speaking, less than and greater than's for y are x equals lines. Less than for x is left, greater than is right. Less than for y is below, greater than is above, because they'll be either vertical or horizontal lines. We'll do B as well, and we'll skip C. Y is greater than 3x plus 4, so this is already solved for you. We're going to graph the line y equals 3x plus 4, but this greater sign means, again, it's a dotted line. Start at 4, go up 3 over 1. So this is how I do it. I make a dash from there to the next spot, 3 over 1, to kind of roughly simulate what's happening. 1, 2, 3, 3. It's not perfect, but it does work. To create the line. Now it says y is greater than that, but if you like to plug in points, greater than, again, we assume is going to be on the left side from the coin dropping technique, so we expect 0, 0 to not work. So is 0 greater than 3 times 0 plus 4? Is 0 greater than 4? No. So that means 0, 0 doesn't work, which means it's the other side that has to be shaded. So how does this all work when you have more than one equation, when you have a system? It means what we have to do is treat them both separately, find out which areas should be shaded for each one, and then the overlap is the area where we will shade our final answer. So let's look at this first one. Y is less than 1/2 x plus 1, and y is greater than or equal to 3x minus 1. So this is a dotted line. This one is a solid line. Less than 1/2 x plus 1, if we start at 1, a slope of 1/2 is rise over 1, 1 over 2. We graph it. We graph it over here as well, and this is dotted. So we do our best to make it dotted looking. Now, we can graph the second one here. It's less than, so we can shade underneath. 0, 0 does work because 0 is less than 1. So this is what area works for this one. Then we have y is greater than or equal to 3x minus 1. Start at -1. This is a solid line, so we start at -1, we're up 3, 1, 2, 3 over 1. And then down 3 into the left one as well. This is a solid line. Now, which areas are above this line? It's the area to the left. If I want to test 0, 0, 0 is greater than or equal to -1, which means 0, 0 is on the side that we want to shade. So that would be here. So what's my solution to the system? It's the area that is shaded by both graphs. Now we know this area isn't shaded by either one. This is just blue, this is just pink. This one was shaded by the blue and the pink, so this region is our actual solution to the system of equations. We can do one more on the next page. You can have more than just two equations. Very often you have constraints that have more than two equations, so we can look at A here, and you just follow that process where it's all the areas that overlap. So we've got y is less than or equal to 2x plus 8. So these are all solid lines. We start at 8. We go up 2 over 1, or down 2 to the left one. Okay, and we graph our line. We've got y is less than or equal to x plus 6. So we start at 6. It's now an up 1 over 1. So y has to be less than both of these lines, and then x is greater than 0 and y is greater than 0 are two vertical lines on our axes. So this is a common set of two that restricts us to just the first quadrant. So I'm looking for the region that is below both of these lines, so below blue and below the pink line. That's also, though, above the x and y axes, which is this area here. Now you'll notice that the blue line doesn't actually create any restrictions because of the others, which is possible for that to happen. And that's really all for 7.1. We'll see applications of this in the next video.